3D printing is one of the most transformative technologies of the modern era, quietly reshaping how products are designed, prototyped, and even manufactured at scale. Also known as additive manufacturing, it works by building objects layer by layer, turning digital designs into physical reality with remarkable precision. The process begins with a 3D model, typically created using computer-aided design software. That model is then sliced into hundreds or even thousands of thin horizontal layers. A 3D printer reads these instructions and deposits material accordingly, constructing the object from the ground up. One of the most common types of 3D printing is fused deposition modeling, or FDM. This method uses a spool of thermoplastic filament, which is heated until it melts and then extruded through a nozzle. The printer moves this nozzle along precise paths, laying down material layer by layer until the object is complete. Materials like PLA and ABS are widely used because they are affordable, versatile, and relatively easy to work with. Another widely used method is stereolithography. Stereolithography. Close enough. Or SLA. Instead of melting plastic, SLA printers use a liquid resin that is cured or hardened by a laser or ultraviolet light. This allows for extremely fine detail and smooth surface finishes, making it ideal for applications like dental models, jewelry design, and highly detailed prototypes. Selective laser sintering, or SLS, takes a different approach. It uses a laser to fuse powdered materials such as nylon into solid structures. One advantage of SLS is that it does not require support structures, since the surrounding powder helps hold the object in place during printing. This makes it especially useful for complex geometries that would be difficult or impossible to produce using traditional manufacturing. 3D printing has dramatically changed the prototyping process. In the past, creating a prototype could take weeks or even months and cost thousands of dollars. With 3D printing, designers can iterate rapidly, producing multiple versions of a design in a matter of hours. This has accelerated innovation across industries, from consumer products to aerospace engineering. In healthcare, 3D printing is enabling breakthroughs that were once considered science fiction. Custom prosthetics can now be designed to fit individual patients with incredible accuracy, often at a fraction of the cost of traditional methods. Surgeons use 3D printed models of organs to plan complex procedures, improving outcomes and reducing risk. There have even been developments in bioprinting, where researchers are working toward printing tissues and eventually functional organs using living cells. The aerospace and automotive industries have also embraced 3D printing. Companies are using it to produce lightweight components that maintain strength while reducing overall weight, improving fuel efficiency and performance. Because additive manufacturing allows for intricate internal structures, engineers can design parts that were previously impossible to create using conventional techniques. Another major advantage of 3D printing is its ability to reduce material waste. Traditional manufacturing methods often involve cutting away material from a larger block, which can result in significant waste. In contrast, additive manufacturing uses only the material needed to build the object, making it more efficient and in many cases more environmentally friendly. However, 3D printing is not without its challenges. Print speed can be relatively slow compared to mass production methods, making it less suitable for large-scale manufacturing in some cases. Material limitations also play a role, as not all materials can be easily printed. Additionally, the strength and durability of printed parts can vary depending on the method and materials used. There are also important considerations around intellectual property and security. As 3D printing becomes more accessible, digital design files can be shared and reproduced easily, raising concerns about copyright infringement and unauthorized production. In certain contexts, there are also concerns about the ability to produce restricted items, which has led to ongoing discussions about regulation and oversight. Despite these challenges, the technology continues to evolve rapidly. New materials are being developed, including advanced composites and metal powders that expand the capabilities of 3D printers. Multi-material printing is becoming more common, allowing a single object to incorporate different properties, such as flexibility and rigidity, within the same print. Large-scale 3D printing is also gaining attention. Entire houses have been constructed using specialized printers that extrude concrete layer by layer. This approach has the potential to reduce construction time and costs, offering new solutions for house and storages in certain parts of the world. At the same time, desktop 3D printers have become increasingly affordable, bringing this technology into homes, schools, and small businesses. This accessibility is fostering creativity and innovation at a grassroots level, enabling individuals to design and produce their own tools, prototypes, and custom products. Looking ahead, 3D printing is expected to play an even greater role in manufacturing and design. As the technology matures, it may shift production closer to the point of use, reducing the need for large inventories and complex supply chains. This could lead to more localized, on-demand manufacturing, fundamentally changing how goods are produced and distributed. 3D printing represents a shift in how people think about making things. Instead of being limited by the constraints of traditional manufacturing, designers now have the freedom to create with far fewer restrictions. Complex shapes, internal structures, and customized designs are no longer the exception. They are becoming the norm. What began as a niche prototyping tool has grown into a powerful and versatile technology with applications across nearly every industry. From healthcare to aerospace to education and construction, 3D printing continues to push the boundaries of what is possible. And as it continues to develop, it is not just changing how things are made, it is changing what can be made at all. Thank you for watching. You're awesome.